Normally induction questions are just sat in isolation, so what I really like about this one is that the result is then used in the second part. Okay, just going to come down here to get a little bit more space. We're told that m is 3a01 and asked to prove by induction that m to the n is this. So let's take a look first at n equals 1. Then according to here, we're going to get m to the 1 is 3, and then a over 2, 3 minus 1, 0, 1. And this is then 3a 0, 1, which is true. Now assume true for n equals k, and show this implies true for n equals k plus 1. Actually, let me just separate that. Just write down the statement first. So if we can show that if it's true for n equals k, that it's then true for n equals k plus 1, what that means is that the statement when n is 1 will imply that it's true for n equals 2, and n equals 2 will imply that it's true for n equals 3, and so on. And because we've shown that it's true for n equals 1, they must all be true. It's quite often good just to write down what we're trying to get to as well. So I'm going to do that here. Not absolutely essential because there's not a lot going on. It's just 3 to the k plus 1 that I'm writing down instead of 3 to the k. All right, now let's get into it. So m to the k plus 1 is going to equal m to the k times m, which is 3 to the k a over 2, 3 to the k minus 1, 0, 1. Now I'm going to multiply through by my m, 3a, 0, 1. And remember, I'm trying to get to this. So multiplying the row by the column, I'm going to get 3 to the k times 3. That's already going to be this perfect. And then this is the most complicated one, 3 to the k a plus a over 2, 3 to the k minus 1. And then when I do the next row by the column, well, I'm just going to get 0. And then that row by that column, I'm going to get 1. So 3 to the k plus 1. Okay. See, this is why it's good to kind of just see where you're headed. I really want to factorize out an a over 2 here. So it'll be a over 2, and then I'll get 2 times 3 to the k plus 3 to the k minus 1. And then I've got to show enough steps here. Like this is actually going to get us exactly that. We're going to get a over 2, then it's going to be 3 times 3 to the k minus 1, and a 0 and a 1 here. And we're there. 3 to the k plus 1, a over 2, 3 to the k plus 1 minus 1, 0, 1. Just a final statement. So true for n equals 1. N equals k true implies n equals k plus 1 true by the principle of mathematical induction. Statement true for all natural numbers n. Right, now to apply this idea. So we're told that triangle T has vertices A, B, and C, and it's transformed to a new triangle by the transformation represented by m to the n for some value of n. Triangle T has an area of 5, and the new triangle has an area of 1,215. And that means the area has been multiplied by 1215 over 5, which is 243. Now, the area scale factor is also given by the determinant of m to the n, which is going to be 3 to the n times 1 minus this, which is just 0. So I can say that 3 to the n is equal to 243. The determinant tells us what the area is being multiplied by, and we know the area has been multiplied by 243. From this, we can get what n is. I mean, you could take logs, or you could just try some values out in this case, like 3 to the 4 is 81, 3 to the 5 is 243, n is 5. And then we're asked for the value of a. Okay, and to do that, we're going to use the second piece of information. So we've got our matrix, and now we can put in n is 5. So this gives us 243, 0. When I substitute 5 into here, I get 243 minus 1, that's 242. Divide by 2, I'm going to get 121a, and a 1 here. So I know that when I multiply this matrix by 2 minus 2, I'm going to get 123 minus 2. And we can multiply the left-hand side to get a. We are going to get 486 minus 242a equal to 123. If you also multiply the bottom one out, you actually just get minus 2 equals minus 2, so that's not particularly useful. But from this, we can work out a, just add the minus 242a to both sides, minus 123, divide 3 by 242, and you'll get a is 1.5. Like I said, I really like that. Bit of proof by induction, and then if you can't do it, you can then use that result in the next part. Well done.